0 minus bh plus 1. So let me see how can we obtain UH plus 3 here. So if m is h plus 2, we have this maximum of ph plus 2, 0 times b1, b2, which is this. And then if let's obtain this, if n is UH plus 1, obtain these exponents with n equal h plus 1. Yes, just this times this. Yes. Finally, the last one is UH plus 4 minus BH plus 3 BH plus 2. Okay, so the exponent in the product is actually this relation dn plus 2 minus dn. So this exponent is 0 and all this disappears. Okay. Good. Then we use that U is a periodic of h plus 2. So U1 is equal to UH plus 3 and U2 is equal to UH plus 4. So we get U1
tutto periodico.
Sì, sì.
tutto periodico, sì. D, the D and the U. So U1 for the moment I just U2 B1 D0 I wrote because what do I need? Maybe we use this relation, the maximum between D1 and 0 times D2. Yes. So I'm using this relation with m equals 0 is 0 plus d2.
Che succede?
D0 plus D2.
So this here should be d0 plus d2. Is it correct? From this relation. With relation.
Ma è recidivo allora.
No, not this relation.
Non sono uguali quei due, no? Dici B equal, no?
Maximum d1 0.
Ah no.
So n equals 0. The maximum between d1 0 times b2 is this with n equals 0.
Sì.
Correct? So it is d0 plus d2. d0 plus d2 times d1 minus d2 d1. Okay, so that these two cancel. Similarly, UH plus 3 is B H plus 2 and then we want to use this relation with
same thing.
M equal H plus 1. Yes. So this is D h plus 1 plus dh plus 3. H plus 1 plus dh plus 3 minus dh plus 1. Finally, UH plus 4, okay, this is just
No, io ci penso che...
minus BH plus 3 times BH plus 3. Okay, now use some periodic, the periodicity of U, so that U1 is equal to UH plus 3. And we have U1 minus U2 D1 plus B.
Lo avevo già fatto.
H plus 2, yes, times BH plus 3. Yeah, of course, I can write H plus 4 instead of H plus 2. If you want. So that you have our periodicity and these two elements are equal because D1 is equal to DH plus 3. The same should be for the pattern. D0, D1 minus B H plus 3, BH plus 2.
Mi sono
In
perso.
this case we don't have to
pezzo.
shift.
Io mi sono perso un pezzo, porca miseria.
Che pezzo?
Ormai è troppo tardi. Ho fatto il calcolo indipendentemente. E allora non mi viene. Uffa. U1 sì, U2 no.
Me l'avevo fatta a casa.
Ma scusa, ma you're not using, so you're cancelling both indices, right? No.
Where? I'm using that U1 is equal to UH plus 3.
No, I'm saying now you prove that the indices of U1 is 0, indices of U2 is 0, coefficient.
The exponent.
The exponent, yes.
Yes.
That's, okay. I'm perso un
This
pezzo.
completes the proof that the U's are periodic.
Ho sbagliato. Detto.
Then we have to show that also the B's are periodic. This is easy. I don't know if you have time to do it.
Ah,
No, vabbè,
no,
sono
ho
periodici
fatto
tutti e
tutto,
due.
mi viene. Oh là.
Che di H.
Sì, per questo molto.
So I complete the proof with the periodicity of the B's, which is easy. Okay.
Come the periodicity of?
B.
Of B, I3. Remember, I wrote here we need to prove that
Sorry.
U is periodic and also the B.
Anche the B, also the B. Ma sarà vero da quello lì, dai, da quello che è scritto lì.
It comes easily from the periodicity of the D.
Sì, non ne posso più.
Sì.
Mi prende sfinimento.
Ma noi no.
No,
Ci
no,
crediamo.
voi non ci credete. Va là, spiritosa.
B13 of D.
Questo è controesempio, questo, che non è più simultaneo.
Quello. Excuse me, Trasburg. Ah, quello è sbagliato.
Ah, quello è sbagliato.
Ci manca un meno.
Ci manca un meno. Ah, delle vite ho sbagliato, non mi sento bene.
Ci manca un meno. Infatti il problema dell'esercizio è trovare quale dei due è un meno, perché deve essere antisimmetrico, che sono
Giusto.
due elementi che sono uguali, no? Però
Quello
così.
di sotto, per eleganza.
Quello.
Sarà quello di sotto.
Sì, quello di sotto. Allora, consider the case where H is odd. if h is odd, b13 t h plus 3 this is minus b13 of t h plus 2.
H odd. No, H odd is H equal 3, right?
Yes, yes.
No, it's ridiculous. Say H odd, H equal 3.
H equal 3, yes. Yes.
No, che sembra tanto generali, capito? In realtà proprio è case by case analysis, it's terrible.
So B13 of T6, since we have the index 1 here, this is minus B13 of T5. Okay. Which is minus P5 by definition. Then B23 of T6 is D6 also by definition. Remember, we have the D when the parity of this is the same as the parity of this. So we cannot use this this case. Then B13 of T1, this is D1, and B23 of T1, this is minus B23 of T2, differentiation. No, of T0. Yes. Actually, I need the index 2 to do the notation this way, which is D0. So we have that we have what we have to prove. You see, B13 of T6, which is minus D5, this is equal to minus D0, and this is B23 of T1. Remember that when H is odd, we have to use the transposition of the first units. So 1 becomes 2, and 2 becomes 1, so these two are equal to this. If H is even, and then in the other cases, we have to obtain that they are equal with the same index, but proof is the same. Actually, yes.
I have a question. So actually this proof would, I mean, why didn't you do case by case analysis to start with? Wouldn't have been simpler? Like say, okay, H equal 2, go over the diagram. H equal 3, go over the diagram, right? Do all the products and check. No, I wonder if it were simpler. I mean, they sort of stubbornly stuck with a general proof, but it doesn't seem to be general at all. It seems to boil down to case-by-case analysis at each step. So I wonder if case-by-case analysis would have simplified, maybe longer but simpler. What do you think? You have examined this more.
You might be right. Yes.
This is like overcomplicated something that after all is case-by-case.
Well, there's a missing point, which
Yeah,
is
I mean,
a key point, because they reduced to the 3.
No, this is understood. This is understood, but I'm
So
saying
it is not
in this
case by
proof.
case, it is a reduction to an n equal 2 and n equal 3 case.
No, but once
How much
the
you say?
reduction
We
is
start with two numbers which might be one or four cases. And it might be that many of the computations are easier to perform if
you know
look at the
what is
special
H.
Yes, yes, H is one of that four numbers, those four numbers.
No, I understand that there is this problem with the
argument
rank.
is the same, and yeah, they try to give this uniform proof with these notations. Yes.
I wouldn't call this a uniform proof, I'm sorry. No, it's really, I wouldn't call it. At each step you're going
Yes.
down to examine all possible cases. You may as well start from special case and examine all of them. No, because people highly regard the uniform proofs. So maybe this is why they wanted it, but it doesn't shed light.
No, they don't say this is a uniform proof, meaning that it doesn't
No,
do
no.
the classification.
It's not that it illuminates the procedure, because at each step this is very opaque. It's not that look, I understand the highway.
No,
No.
we use the fact that we obtain these relations on
Yes,
this DM, and the fact that we know that this recursion gives periodicity if and only if we are in the finite case. So,
Ah.
so yes.
But like
So this proof of the exponents dm holds in all cases, also if we are not in the finite case.
Then it makes sense. Okay.
And it says that these are not.
Future use.
But I don't know if this is useful.
No, it's good. So what is the plan?
The plan is, I don't know, I want to show you this example which is at the end of this paper,
Yes,
which is
yes.
rather nice.
Example
and it
is very
shows an
important.
application of this theorem.
Yes, okay. So next time, right?
Next time, yes, because it's very
And then
long.
is our last meeting in April, because then
yes,
there is a holiday, 1st of May.
yes. So, for the example.
Okay, so this will